Imagine standing on a hillside 12,800 years ago. The ice has been retreating for centuries. Green valleys stretch before you. Rivers run full with meltwater. Herds of mammoth graze in meadows that only your grandparents remember being frozen solid. The world is warming. Life is returning. Your people have survived the worst of the Great Ice Age. For generations, they endured glaciers 2 miles thick covering the northern lands. Now those glaciers are melting. The forests are expanding. Food is becoming more abundant with each passing season. You look up at the evening sky. The stars are bright and familiar. There is no reason to believe that everything is about to change. No reason to suspect that within a single human lifetime, the cold will return with terrifying speed. But something is already falling through the atmosphere. Fragments of a disintegrating comet, some as large as cities, are streaking toward the Earth at speeds your mind cannot comprehend. They have traveled millions of miles through the darkness of space. And tonight, some of them will reach the surface. Others will explode in the atmosphere with the force of thousands of nuclear weapons combined. The sky will turn white. The ground will shake beneath your feet. And across the northern hemisphere, fires will ignite that burn millions of square miles of forest. Within hours, the smoke will begin to block the sun. Within weeks, temperatures will plummet. Within months, the rivers that were flowing freely will begin to freeze again. Within years, the glaciers that have been retreating will start advancing once more. The warmth your people had come to depend on will vanish. And the cold that follows will last for 1,200 years. This is not science fiction. This is not speculation built on thin air. This is a story written in layers of rock, in ancient ice cores, in the bones of extinct animals, and in the sudden, mysterious disappearance of entire human cultures across the planet. It is one of the most dramatic events in the history of our species. And yet, most people have never heard of it. The Younger Dryas, a period so devastating, so abrupt, and so mysterious that scientists have argued about its cause for decades. It sits at the boundary between the ancient world and the modern one. It separates who we were from who we became. And the evidence suggests that it began with an impact from space. Picture the Earth as it was just before this catastrophe. Imagine a world where humans were already building, already creating, already developing the earliest hints of what we might call civilization. They were painting caves, crafting tools, and possibly constructing monuments we have yet to discover. Then imagine all of that progress being erased in a single terrible season. What would that do to a people? What would it do to their memory, their knowledge, their understanding of the world? How would they explain such sudden destruction? And how would they survive the 12 centuries of darkness that followed? These are the questions that haunt the Younger Dryas. Tonight, we are going to explore what happened during those 1,200 years. We are going to follow the evidence from the moment of impact to the long cold centuries that came after. We will walk alongside the people who endured it. We will look at what science has uncovered in ice cores drilled from the Greenland ice sheet. We will examine the thin black layer of soot and nanodiamonds found on 4 continents. We will listen to the ancient stories that cultures around the world still tell. Stories of fire from the sky. Stories of floods that swallowed the land. Stories of a long winter that nearly ended everything. And we will ask a question that mainstream science has been reluctant to answer fully. Did this catastrophe reset human civilization? Did it destroy something that came before? Something we have only glimpsed in fragments and riddles and ruins that seem impossibly old? The Younger Dryas is not just a chapter in climate history. It is possibly the most important event in the human story that nobody taught you about in school. It sits at the heart of mysteries that range from the extinction of the great megafauna to the sudden emergence of agriculture, to the flood myths shared by nearly every culture on Earth. Tonight, we will explore what happened and why the clues still do not entirely add up. We will move gently through the evidence, piece by piece, layer by layer. This is a story told in whispers preserved in stone and ice and bone. So settle in. Let the world outside grow quiet. We are going back 12,800 years, to the night the sky caught fire and the world went cold. We are going to walk through the longest winter humanity has ever faced. And we are going to discover what it means for us today. Because the universe has not finished with us yet. The forces that sent those fragments hurtling toward Earth are still out there. The debris stream still exists. And as we will see, the cycle of catastrophe may be far more regular and far more predictable than anyone wants to admit. This is the story of how we almost lost everything. This is live 12,800 years ago. Chapter 2. Why the Younger Dryas changes everything. To understand why the Younger Dryas matters, you first need to understand what the world looked like before it happened. You need to feel the warmth that was returning and appreciate the hope that was building across human communities on every inhabited continent. For roughly 100,000 years, the Earth had been locked in a glacial period. Massive ice sheets covered much of North America, Europe, and parts of Asia. Sea levels were hundreds of feet lower than today. Coastlines extended miles beyond where they sit now. Humans lived through this ice age. They adapted, migrated, and survived in some of the harshest conditions our species has ever faced. They hunted mammoths and mastodons. They sheltered in caves and built structures from bone and hide against the relentless cold. Then, around 20,000 years ago, the ice began to melt. Slowly at first, then faster. By 15,000 years ago, the warming was unmistakable. Glaciers were retreating across the northern hemisphere. Forests were replacing tundra. Animals were moving into territories that had been buried under ice for millennia. By 13,000 years ago, the world was approaching conditions not unlike our own. The warming was dramatic and sustained. Human populations were expanding. In North America, a culture known as the Clovis people had spread across the continent. They were skilled hunters. They made beautifully crafted stone tools. Their distinctive spear points have been found from coast to coast. They represented one of the most successful human adaptations in the Americas. They were thriving in a world that seemed full of promise. Then, almost overnight in geological terms, it all stopped. The warming reversed. Temperatures in the northern hemisphere dropped by as much as 14 degrees Fahrenheit in just a few decades. In some regions, the change was even faster. Ice core data from Greenland suggests that the most severe cooling happened in as little as a single year. 1 year. Think about that. Imagine living through a single winter that never truly ends. Imagine watching the rivers freeze in summer. Imagine seeing the herds that sustained your people begin to vanish as the grasslands die and the forests retreat before the advancing cold. This is what happened during the Younger Dryas, and it did not last a decade or a century. It lasted 1,200 years. 40 generations of human beings were born, lived, and died in a world that had been suddenly and violently returned to Ice Age conditions. 40 generations of cold and scarcity and struggle. Now here is why this matters beyond the historical curiosity. If the Younger Dryas was caused by a cosmic impact, it changes our understanding of how vulnerable human civilization truly is. It means that the progress we take for granted, our cities, our technology, our global food systems, could be disrupted by forces entirely beyond our control. It means that this has happened before, and it could happen again. But the implications go even deeper than that. If there were human societies before the Younger Dryas that were more advanced than we currently recognize, and if those societies were destroyed or severely disrupted by this catastrophe, then our timeline of civilization itself may be wrong. We are taught that civilization began around 6,000 years ago in Mesopotamia. Writing, agriculture, cities, government. All of it emerging as if from nowhere in the ancient Near East. But what if it did not come from nowhere? What if it was a rebuilding? What if the survivors of the Younger Dryas carried fragments of earlier knowledge? This is not a fringe idea anymore. The discovery of Göbekli Tepe in Turkey, a massive stone monument complex dating to nearly 12,000 years ago, has shattered the assumption that pre-agricultural humans could not organize complex construction projects. Göbekli Tepe was built right at the end of the Younger Dryas. Its carved pillars depict animals. Some researchers believe one particular pillar encodes the date of the cosmic impact itself. If true, the builders were commemorating the very catastrophe we're discussing tonight. They were remembering. They were warning. And they were not supposed to exist. Not according to the old timeline. The stakes of the Younger Dryas debate are enormous. If the impact hypothesis is correct, it means a cosmic event wiped out the megafauna of North America, including mammoths, saber-toothed cats, giant ground sloths, and dozens of other species in a geological instant. It means the Clovis culture did not simply fade away due to normal pressures. It was obliterated. Their population collapsed alongside the animals they hunted. The archaeological record shows a sharp break. Clovis tools disappear. What follows is something different and diminished. It means the great flood stories told by cultures around the world, from the Epic of Gilgamesh to the Hebrew Bible to the oral traditions of indigenous peoples across the Americas, may not be myth at all. They may be memory. Memory of the ice melting catastrophically. Memory of coastlines drowning as meltwater pulses sent sea levels surging. Memory of a world transformed by forces that the survivors could only describe as the anger of the gods or the judgment of the sky. If even a fraction of this is true, we are not the first attempt at civilization. We are the second, or perhaps the third. And the force that knocked humanity back into the dark ages of survival was not human folly. It was a rock from space. That possibility should keep us awake at night. But tonight, we will let it guide us gently through the evidence. We will examine what science has found. We will weigh the arguments for and against. And we will ask what all of this means for the story we tell ourselves about who we are. Because the Younger Dryas is not just about the past. It is a mirror held up to the present. It asks us whether we are prepared for the possibility that the universe does not care about our plans. It asks whether we have learned anything from the catastrophe that nearly ended our story 12,800 years ago. The answer, as we shall see, is complicated and humbling. Chapter 3. A world emerging from the ice. To truly understand the catastrophe of the Younger Dryas, we must first understand the world it interrupted. We must go back further to the Great Ice Age itself and see the Earth as our distant ancestors knew it. A planet gripped by cold. The last glacial maximum occurred roughly 26,000 years ago. At its peak, ice sheets covered approximately 30% of the Earth's land surface. In North America, the Laurentide ice sheet stretched from the Arctic to what is now New York City. In places, this ice was more than 2 miles thick. Try to picture that. Stand in modern Chicago and look up. Now imagine ice rising above you, higher than any skyscraper ever built. A wall of frozen water so massive that its weight pressed the bedrock of the continent downward by hundreds of feet. Europe had its own ice sheet. Scandinavia was buried. The British Isles were connected to the continent by dry land because so much water was locked in ice that sea levels sat nearly 400 feet below where they are today. The world map looked entirely different. Australia was connected to New Guinea. Indonesia was a vast peninsula joined to mainland Asia. You could walk from Siberia to Alaska across a land bridge called Beringia that stretched 1,000 miles wide. This is how humans first entered the Americas, or so we have traditionally been told. Life during the glacial maximum was harsh, but not impossible. Humans have been dealing with ice ages for hundreds of thousands of years. Our species, Homo sapiens, evolved in Africa during a glacial period. We are, in many ways, creatures shaped by cold. But the cold of the last glacial maximum tested every survival skill our ancestors possessed. Populations contracted. Groups that had once ranged freely across continents were pushed into refugia, small pockets of habitable land where they waited out the worst of the freeze. Southern France, the Iberian Peninsula, parts of Southeast Asia, pockets of Africa. These refugia became the nurseries of human survival, places where small bands maintained the knowledge and genetic diversity that would allow our species to bounce back when the ice retreated. And retreat it did. Around 20,000 years ago, the slow warming began. Orbital cycles of the Earth shifted the amount of sunlight reaching the northern hemisphere. Ice began to melt. At first, the changes were imperceptible to anyone living through them. But over centuries, the transformation became undeniable. Glaciers that had stood for tens of thousands of years started releasing torrents of meltwater. Rivers carved new channels. Lakes formed where ice had been. The tundra that bordered the ice sheets began to give way to grassland. Grassland gave way to forest. Animals followed the retreating ice northward. Mammoth herds moved into fresh grazing territory. Caribou, horse, and bison expanded their ranges. Behind them came the predators, both animal and human, who depended on these herds for survival. By 15,000 years ago, the warming was accelerating. The period known as the Bowling-Allerode Interstadial had begun. Temperatures in the northern hemisphere rose sharply. In Greenland, ice core records show warming of several degrees in just decades. The world was waking up from its long frozen sleep. This was a time of expansion and possibility for human cultures. In Europe, the Magdalenian culture flourished. These were the people who painted the stunning cave art at Lascaux and Altamira. They made bone needles, carved figurines, and developed increasingly sophisticated hunting strategies. Their populations were growing. In the Levant, the Nachifian culture was emerging. These people built some of the earliest known permanent settlements. They harvested wild grains. They buried their dead with elaborate grave goods. They were taking the first tentative steps toward what would eventually become agriculture and sedentary life. In North America, the Clovis people appeared around 13,500 years ago. Named after the town in New Mexico, where their distinctive fluted spear points were first discovered, the Clovis culture spread rapidly across the continent. They were remarkably successful. Clovis sites have been found from coast to coast, from the deserts of the Southwest to the forests of the Southeast to the plains of the Midwest. Their technology was elegant and effective. They hunted the great megafauna that roamed North America in astonishing abundance. Mammoths, mastodons, giant bison, camels, horses. North America, 13,000 years ago, was a world that rivaled the Serengeti in its diversity of large animals. And the Clovis people were at the top of the food chain. Everything pointed toward continued warming and continued human flourishing. The ice was melting. The world was greening. Human populations were growing on every continent. The long nightmare of the Ice Age appeared to be ending at last. A new chapter in the human story was beginning, and then something happened. Something that would send temperatures plunging. Something that would bring the glaciers surging back. Something that would extinguish dozens of animal species and collapse human cultures across the northern hemisphere in what may be the most sudden catastrophe since the asteroid that killed the dinosaurs. That something left its signature in a thin, dark layer of sediment found across 4 continents. And its story was about to be written in 1,200 years of ice and silence. We are approaching the moment of impact. Chapter 4. The Black Mat and the Missing Animals. The first clue was hiding in plain sight for decades. Archaeologists working at Clovis sites across North America kept finding the same strange thing. A thin, dark layer of sediment sitting directly on top of the last Clovis artifacts. They called it the Black Mat. Below the Black Mat, you find Clovis tools. You find the bones of mammoths and other megafauna. You find charcoal from ancient campfires. You find evidence of a thriving human culture interacting with a rich and abundant ecosystem. Life is clearly present. Above the black mat, the Clovis tools vanish. The megafauna bones vanish. The charcoal from campfires becomes sparse or disappears entirely. Whatever was living and hunting below that dark layer of sediment was gone by the time the sediments above it were deposited. Something happened at that boundary. For years, the standard explanation was simple. The Clovis people hunted the megafauna to extinction, the theory went. Humans arrived in the Americas, encountered animals that had never seen a two-legged predator, and simply killed them all. The overkill hypothesis was clean, straightforward, and widely accepted in academic circles. But there were problems with this explanation. The timing was too sudden. Across the entire continent, dozens of species vanished within the same narrow window. Mammoths, mastodons, saber-toothed cats, direwolves, giant ground sloths, short-faced bears, American horses, American camels. Gone. All of them. Almost simultaneously. Could a relatively small human population really have hunted that many species to extinction across an entire continent in just a few hundred years? Some researchers found this deeply implausible. The numbers simply did not add up. And there was another problem. The Clovis people themselves seemed to vanish at the same time as the animals they supposedly hunted to extinction. If you successfully eliminate your prey, you might decline, but you do not disappear from the archaeological record overnight. Something else was happening. Then, in 2007, a team of scientists proposed a radical new hypothesis. Richard Firestone, Alan West, and a group of 23 other researchers published a paper that would ignite one of the most heated debates in modern Earth science. They proposed that the Younger Dryas cold period was triggered by a cosmic impact event. Their evidence came from that black mat. When they analyzed the thin, dark layer at Clovis sites across the continent, they found something extraordinary. The sediment contained microscopic nanodiamonds. These tiny carbon structures form only under conditions of extreme heat and pressure, conditions like those produced by an impact. They found magnetic microspherules, tiny iron-rich beads that form when material is heated to temperatures exceeding the melting point of iron and then rapidly cooled. These spherules were scattered through the boundary layer at site after site. They found elevated levels of iridium. This element is rare on Earth's surface, but common in meteorites and comets. Its presence in a geological layer is one of the classic signatures of a cosmic impact. The same marker was used to identify the asteroid that killed the dinosaurs. They found carbon spherules and gloss-like carbon. They found evidence of massive wildfires in the form of soot and charcoal concentrated at the boundary. And they found all of these materials at roughly 50 sites across North America, distributed in a pattern consistent with a large-scale airburst or multiple impacts. The implications were staggering. If correct, this meant that approximately 12,800 years ago, fragments of a comet or asteroid had struck the northern hemisphere or exploded in the atmosphere with enough force to ignite continental-scale wildfires, destabilize the climate, and trigger a return to Ice Age conditions. The team proposed a specific mechanism for the cooling. The impacts, they argued, struck or destabilized the Laurentide ice sheet. Massive amounts of fresh water were suddenly released into the North Atlantic Ocean. This influx of cold fresh water disrupted the Atlantic meridional, overturning circulation, the great ocean conveyor belt that carries warm water northward. When that conveyor belt shut down, the northern hemisphere lost its primary source of oceanic heat transport. Temperatures plummeted. Ice began to reform. And the Younger Dryas cold period began, lasting for 1,200 brutal years. The scientific community was divided. Some researchers embraced the hypothesis. The evidence at the boundary layer was compelling and widespread. Independent teams began finding the same markers at sites in Europe, the Middle East, and even South America. The impact signatures appeared to be a global phenomenon. Others pushed back hard. Critics argued that nanodiamonds could form through other processes. They questioned the dating of some sites. They suggested that the microspherules might have terrestrial origins. The debate became fierce, with papers published attacking and defending the hypothesis in rapid succession. But the evidence kept accumulating. In 2012, researchers found an impact layer at Abu Huraira in Syria. This ancient settlement showed clear signs of catastrophic burning at the Younger Dryas boundary. The temperatures required to produce the materials found in the layer exceeded those of any known volcanic eruption. The site contained melt glass, material formed when the ground itself is heated to temperatures above 3,000 degrees Fahrenheit. This does not happen in ordinary fires. It does not happen in volcanic eruptions at that latitude. It happens in impacts. In 2013, analysis of the Greenland ice sheet revealed a large platinum anomaly at exactly the Younger Dryas boundary. Platinum, like iridium, is associated with extraterrestrial material. Its spike at precisely this moment added another line of evidence supporting the impact hypothesis. By 2018, the discovery of the Hiawatha crater beneath the Greenland ice sheet sent shockwaves through the scientific community. This 31-kilometer-wide impact crater appeared to be geologically young. Some researchers suggested it could be the smoking gun. The dating of the Hiawatha crater remains debated. Some analyzers place it within the right time frame for the Younger Dryas impact. Others suggest it may be older. The ice sheet that covers it makes precise dating extraordinarily difficult. But its mere existence proved that large impacts had struck Greenland in the geologically recent past. Meanwhile, the biological evidence painted its own grim picture. The extinction event at the Younger Dryas boundary was one of the most severe in the last million years. In North America alone, 35 genera of large mammals disappeared. Many of these animals had survived multiple ice ages over hundreds of thousands of years. They survived glacial advances and retreats. They survived shifts in vegetation and climate that unfolded over millennia. But they did not survive whatever happened 12,800 years ago. Something about this event was different from anything that came before. And the human toll was equally devastating. The Clovis culture, which had been the dominant human presence in North America, collapsed at the boundary. What replaced it was a patchwork of smaller, more localized cultures using different technologies. The continent-wide unity of the Clovis tradition was shattered. Population estimates suggest a dramatic decline in human numbers across North America at precisely this moment. People did not just change their tool-making traditions. They died in large numbers. And those who survived faced a world that had been fundamentally transformed. But here is the detail that haunts researchers most. The evidence for this catastrophe does not exist only in North America. It appears on 4 continents. It appears in ice cores and sediment layers and peat bogs around the world. Whatever happened 12,800 years ago was not a local event. It was global. And if it was global, then its effects on human populations were not limited to the Clovis people. Every culture on Earth would have felt the impact. Every community would have faced the sudden return of cold, the loss of food sources, the collapse of the ecosystems they depended upon. Somewhere in the Middle East, the Nachafian people watched their world change. Somewhere in Europe, the descendants of the cave painters faced a new darkness. Somewhere in Southeast Asia, coastal communities saw the warming seas suddenly grow cold and hostile, and all of them had to find a way to survive. What happened to these people during the 1,200 years of cold that followed? How did they adapt? What did they lose? And what fragments of their experience survived in the myths and monuments they left behind? The black mat tells us when the catastrophe began. The nanodiamonds tell us what caused it. But the full story of what happened next, during those long, dark centuries, remains one of the great untold chapters of human history. And it is a chapter that begins not with the impact itself, but with the morning after. when the fires burned out and the smoke blocked the sun and the temperature began its long and terrible fall. When the survivors looked around at a world they no longer recognized. What did they do? Where did they go? And how did humanity claw its way back from the edge of extinction during 1,200 years of darkness? That story lies just ahead. Chapter 5. The cracks in the official story. The morning after the end of the world does not announce itself with trumpets. It arrives in silence. A silence so complete that the absence of birdsong becomes its own kind of sound. You wake in a landscape you no longer recognize. The sky has changed color. Where once it held pale blue certainties, it now carries a permanent haze. Fine particulate matter from continent-wide fires has entered the upper atmosphere. Sunlight filters through weakly. The temperature has already begun to drop. But here's where the story fractures from what you were taught. Here is where contradictions emerge that mainstream archaeology has struggled to reconcile for decades. Because the standard narrative says this was simply a cold snap, a return to glacial conditions caused by ocean current disruption. Nothing more. The standard narrative says that humans during the Younger Dryas simply adapted. They hunted smaller game. They moved to warmer regions. They waited out the cold and eventually built Göbekli Tepe when conditions improved. A clean story. A comfortable one. But the evidence tells something far more complicated. Let us start with the first contradiction. Göbekli Tepe itself. This site in southeastern Turkey features massive carved pillars weighing up to 20 tons. They display sophisticated astronomical knowledge, animal reliefs of extraordinary artistic skill, complex geometric patterns requiring advanced planning and coordination among hundreds of workers. Radiocarbon dating places its earliest construction phase around 11,600 years ago. That is the very end of the Younger Dryas, the exact moment the cold released its grip. And here's the problem that keeps archaeologists awake at night. You do not emerge from 1,200 years of brutal survival conditions and immediately build a megalithic temple complex. You do not go from scattered bands of desperate foragers to organizing massive construction projects overnight. The skill had to come from somewhere. The knowledge had to precede the building. This means one of two things. Either the builders developed their expertise during the Younger Dryas itself, which contradicts the idea of civilizational collapse, or they inherited it from before the catastrophe, from a tradition that somehow survived 12 centuries of darkness. Neither answer fits comfortably within current models. Now consider the second contradiction. The Clovis culture vanishes from the archaeological record precisely at the Younger Dryas boundary. Their distinctive fluted projectile points simply stop appearing. For decades, archaeologists explained this as cultural evolution. People changed their tool styles, but the replacement cultures that appear afterward show no gradual transition. There is a gap, a silence in the sediment. And when new tool traditions emerge, they often bear no resemblance to Clovis technology. This is not evolution. This looks like interruption, complete cultural discontinuity. The third contradiction involves population genetics. Studies of ancient DNA from North American sites show dramatic population bottlenecks coinciding precisely with the Younger Dryas onset. Some lineages disappear entirely. Others show the genetic signatures of populations reduced to mere hundreds of individuals. If this were simply a gradual cooling, you would expect slow migration and adaptation. Instead, the genetic evidence suggests sudden catastrophic population loss followed by long periods of isolation. Small groups cut off from each other. Genetic drift accelerating in tiny surviving bands. Now here is something rarely discussed. The black mat layer, the dark organic-rich sediment marking the Younger Dryas boundary, has been found at over 50 sites across 4 continents. Below this layer, you find abundant evidence of human activity. Stone tools, hearths, animal bones with cut marks. Above the black mat, in many locations, there is nothing. No human presence whatsoever. Sometimes for centuries. The people simply vanish from those places. Not gradually. Not through slow migration. They were there, and then they were gone. The fourth contradiction involves Abu Huraira in Syria. This site was excavated before the Topka Dam flooded it permanently in the 1970s. Among the preserved materials, researchers in 2012 found melt glass that formed at temperatures exceeding 2,000 degrees Celsius. No ordinary fire produces such temperatures. No volcanic activity existed in that region. The melt glass contained minerals that form only under extreme rapid heating consistent with cosmic airburst events. An entire village appears to have been subjected to temperatures hot enough to melt earth into glass. And this was not a military installation or industrial site. This was a small settlement of early farmers and foragers. People grinding grain and storing seeds. People whose quiet daily existence was interrupted by something that turned their soil into glass. The fifth contradiction concerns the megafauna extinction itself. The overkill hypothesis proposed that human hunters drove 35 genera to extinction across North America. But mathematical models consistently show this was impossible given estimated human population densities at the time. Furthermore, many extinct species show no evidence of human hunting pressure whatsoever. Some species that were heavily hunted survived. Some that were rarely hunted vanished. The pattern does not match selective hunting pressure. It matches sudden environmental catastrophe affecting entire ecosystems simultaneously. Consider the timeline anomaly. Horses survived in North America for millions of years through multiple ice ages and warming periods. They adapted to every climate shift the Pleistocene could deliver. Then, 12,800 years ago, they vanished from the continent entirely. Every single horse gone. Camels had lived in North America for 40 million years. Gone. Giant. Ground sloths had survived for 30 million years through countless climate oscillations. Gone. These were not fragile species vulnerable to minor temperature changes. These were resilient survivors of deep evolutionary time. Something unprecedented happened at the Younger Dryas boundary. Something beyond normal climate variation. Something beyond human hunting capability. And when you stack these contradictions together, a picture emerges that the standard narrative cannot contain. The evidence does not whisper. It speaks clearly to anyone willing to listen without preconception. 12,800 years ago, something shattered the trajectory of life on this planet. And what followed was not mere inconvenience. What followed was an age of darkness. And within that darkness, something extraordinary happened to the survivors. Something that challenges everything we think we know about the origins of civilization itself. But to understand what they endured, we must first listen to the stories they left behind. Stories dismissed for centuries as primitive mythology. Stories that may be humanity's oldest and most accurate historical records. Chapter 6. When myth becomes memory, every ancient culture on Earth tells the same story. The world was destroyed. Fire fell from the sky. Water rose and swallowed the land. A long darkness followed. And a handful of survivors carried the memory forward through generations until someone finally wrote it down. We call these flood myths. We categorize them as primitive attempts to explain local river flooding or seasonal storms. We pat our ancestors on the head and assure ourselves they were simply frightened by nature and invented stories to cope with their ignorance of meteorology. But what if we have the relationship exactly backward? What if these are not myths at all? What if they are testimony? The Sumerian flood narrative predates the biblical account by at least 1,000 years. In it, the god Enlil decides to destroy humanity. Utnapishtim is warned. He builds a vessel. The catastrophe comes with wind and water and darkness that terrifies even the gods themselves. The storm lasts 7 days. The Hindu tradition describes a great flood in the Matsya Purana. Manu, the first man, is worn by a fish avatar of Vishnu. He builds a boat. He preserves the seeds of all living things. The waters cover everything. When they recede, Manu repopulates the world. The Ojibwe people of North America tell of a great flood sent by spirits. The Caddo people describe fire from the sky followed by massive flooding. The Ute people speak of a time when the sun was shattered and the world went dark and cold for an age beyond memory. In South America, the Mapuche describe a cosmic battle between serpents that caused the seas to rise and drown the lowlands. Survivors fled to mountain peaks. The Muisca people of Colombia tell of waters that covered the entire world until a hero figure made them recede. The Aboriginal Australians carry oral traditions describing sea level rise that geologists have confirmed matches the actual flooding of coastal areas at the end of the last ice age. These stories have been verified as accurate memories preserved for over 7,000 years. Now pause and consider the implications. If Aboriginal oral traditions accurately preserve memories of sea level changes over 7 millennia, what other ancient stories might contain genuine historical information encoded in mythological language? The Greek tradition gives us Phaethon, son of Helios, who lost control of the sun chariot and scorched the earth before Zeus struck him down with a thunderbolt. The earth burned. Rivers boiled. The climate changed catastrophically. Scholars have long dismissed this as allegory. But read the story again with fresh eyes. An object associated with celestial fire streaks across the sky. The earth burns beneath it. The climate shifts violently. Rivers are disrupted. This is not allegory. This is an eyewitness account filtered through thousands of years of retelling. Plato described the destruction of Atlantis in his dialogues Timaeus and Critias. He placed this destruction approximately 9,000 years before Solon's visit to Egypt around 600 BCE. That arithmetic places the event approximately 11,600 years ago, squarely within the Younger Dryas window. Plato specifically stated that Egyptian priests told Solon about cyclical destructions of civilization by fire and flood. They said the Greeks had forgotten their own ancient history because catastrophes periodically destroyed their records and forced them to begin again like children. Whether Atlantis existed as described is not the essential question. The essential question is whether Plato accurately transmitted an Egyptian tradition about civilizational destruction that aligns with the physical evidence of the Younger Dryas impact. Now consider the out-of-place evidence. Pillar 43 at Göbekli Tepe, known as the Vulture Stone, displays carved figures that researchers from the University of Edinburgh interpreted in 2017 as astronomical markers. They proposed it encodes the date of the Younger Dryas impact. Using precession calculations, the animal symbols on the pillar correspond to specific star positions that would have been visible around 10,950 BCE. This matches the Younger Dryas onset to within a few decades. A stone monument apparently recording the date of a cosmic catastrophe in astronomical code. The Younger Dryas boundary layer contains concentrations of platinum that match the geochemical signature of certain types of meteorites. This platinum anomaly has been found in ice cores from Greenland, in sediments from North America, Europe, and the Middle East. It is not localized. It is global. In 2018, researchers discovered evidence of a massive biomass burning event at the Younger Dryas boundary. Charcoal and soot levels in sediment cores from around the world show that approximately 10% of Earth's terrestrial biomass burned within a very short time frame. 10% of all plant life on the planet burning simultaneously. No known terrestrial mechanism produces such a signature. Volcanic eruptions are regional. Human-set fires are local. Only a cosmic impact or airburst event distributes energy broadly enough to ignite fires across multiple continents simultaneously. There is more. Researchers studying Carolina Bays, the 500,000 elliptical depressions scattered across the eastern United States, have noted their parallel alignment. They all point toward the same general area, the Great Lakes region, where the Laurentide ice sheet sat 12,800 years ago. For decades, geologists explained Carolina bays as wing-formed features or dissolved limestone depressions. But their consistent elliptical shape, their parallel orientation, and their sheer number resist easy conventional explanation. Some researchers propose they are secondary impact features from ejecta launched by a primary impact on the ice sheet. The Hiawatha crater beneath Greenland's ice may be the smoking gun, 31 kilometers wide, potentially formed by an iron meteorite 1.5 kilometers across. If its dating is confirmed to match the Younger Dryas, it would transform this hypothesis from compelling theory to established fact. And still the established institutions resist. Still the textbooks present the Younger Dryas as a simple climate oscillation. Still the myths are dismissed. Still the physical evidence is debated into deadlock. The question is not whether the evidence exists. It does, in abundance. The question is why we are so reluctant to accept what it is telling us. Perhaps because accepting, it means accepting something far more unsettling about our place in time. Chapter 7. The cycle that has not ended here is what is truly at stake. And it is larger than a single catastrophe 12,800 years ago. It is larger than the Younger Dryas. It is larger than the megafauna extinction, or the fall of the Clovis people, or the burning of 10% of Earth's biomass. What is at stake is our understanding of human civilization itself, its origins, its fragility, and the question of whether it has happened before. Let us be precise about what the evidence suggests. Before the Younger Dryas impact, humans had already been anatomically modern for at least 200,000 years. They had the same brain volume, the same cognitive architecture, the same capacity for language, abstract thought, and innovation. For the vast majority of those 200,000 years, the archaeological record shows relatively simple tool use and small nomadic bands. Then, right at the end, right before the Younger Dryas boundary, there is an explosion of sophistication. Cave art, complex hunting strategies, long-distance trade networks, possible astronomical knowledge, and then catastrophe. And then silence. And then, 1,200 years later, Göbekli Tepe appears fully formed, as if from nowhere, as if someone remembered how. The conventional timeline of civilization says that humans invented agriculture independently in several locations around 10,000 to 12,000 years ago. Cities followed. Writing followed. Mathematics followed. Everything we call civilization emerged in a neat upward trajectory over the last 10,000 years. But what if that trajectory is not the first one? What if there was an earlier arc of development that was shattered at the Younger Dryas boundary? Not necessarily cities with skyscrapers, not necessarily technology as we understand it, but organized societies with accumulated knowledge far beyond what we have credited. Consider what 1,200 years of cold would do to such knowledge. Imagine a society that understood agriculture, astronomical cycles, engineering principles, and complex social organization. Now subject that society to a sudden catastrophic impact followed by over a millennium of harsh conditions. Within a single generation, the infrastructure collapses. Within 2 generations, the specialists who maintain knowledge die without transmitting it fully. Within 5 generations, the knowledge becomes oral tradition. Within 10 generations, oral tradition becomes myth. Within 40 generations, 1,200 years, nearly everything is lost. What survives are fragments, encoded in stories, preserved in ritual, carved into stone by those who remembered just enough to know that remembering mattered. Göbekli Tepe may not be the beginning of civilization. It may be a memorial to its destruction. Now let the stakes escalate further, because the Younger Dryas impact was not a unique event in Earth's history. The geological record shows that our planet has been struck repeatedly by cosmic objects throughout its existence. The Chicxulub impactor 66 million years ago killed the dinosaurs. The Tunguska event in 1908 flattened 2,000 square kilometers of Siberian forest. The Chelyabinsk meteor in 2013 exploded over Russia with 30 times the energy of the Hiroshima bomb. These are not ancient history. These are events within living memory or recent geological time. The Taurid meteor stream, through which Earth passes twice annually, contains debris from a giant comet that fragmented sometime in the last 20 to 30,000 years. Astronomers have identified objects within this stream large enough to cause regional or global catastrophe if they were to strike Earth. The astronomer Victor Klube and astrophysicist Bill Napier proposed in the 1980s that coherent meteor streams pose a recurring threat to civilization. They argued that the Younger Dryas impact may have been caused by a fragment from exactly this Taurid complex. If they are correct, then the threat is not past. It is cyclical. The same debris field that produced the Younger Dryas catastrophe still orbits the Sun. Earth passes through it predictably, and within that stream, unseen objects of significant size continue their ancient paths. This is not speculation designed to frighten. This is orbital mechanics. This is physics. The objects exist. Their orbits are calculated. The intersection with Earth's path is real and recurring. The question is not whether another encounter will happen, but when. And here's where the mythological evidence becomes not quaint but urgent. Cultures around the world describe cyclical destructions. The Hindi Yugas, the Aztec Five Suns, the Hopi World Ages, the Norse Ragnarok, followed by renewal. These traditions do not describe a single catastrophe. They describe a pattern. What if these cycle myths are not philosophical abstractions, but inherited warnings? Compressed memories of repeated catastrophic encounters passed down by survivors who understood that what had happened before would happen again, and who desperately wanted future generations to remember. We dismissed them. We called them primitive. We filed them under mythology and folklore and moved on to more serious matters. Meanwhile, the debris stream continues its orbit, and Earth continues its passage through it twice every year. Now bring this back to the 1,200 years of darkness, because the survivors of the Younger Dryas impact did something remarkable. They did not simply endure. They encoded their experience. They built monuments aligned to stars. They carved records into stone. They told stories with such precision that the information survived millennia. They did this because they understood what we are only now beginning to grasp. Civilization is not permanent. Knowledge is not guaranteed. The continuity of human achievement depends on the fragile thread of transmission from one generation to the next. Break that thread and everything unravels. 40 generations of cold. 40 generations of diminished resources and contracted populations and shortened lives. 40 generations during which the memory of what had been was slowly, inexorably, fading. And yet, something survived. Something was carried through the darkness by people whose names we will never know. What did they preserve? How did they preserve it? What methods did they develop to encode critical knowledge in forms that could withstand centuries of degradation? And what does their experience tell us about our own vulnerability to the same forces that nearly erased them? The answers are written in stone and ice and sediment. They are encoded in stories we have been telling for 12,000 years without understanding what they mean. They are hidden in the precise alignments of monuments we have refused to take seriously, and they are running out of time to be understood, because the next passage through the Taurid stream is not ancient history. It is approaching. It is calculable. And we have spent the last century ignoring the warnings that our ancestors carved into the bedrock of human memory. What happened during those 1,200 years of darkness is not merely an archaeological curiosity. It is a survival manual written by people who lived through the worst catastrophe in human memory, a manual we have barely begun to read. And the most critical chapter of that manual the one that describes what the survivors actually did, how they organized, what they sacrificed, and what they chose to remember, lies buried in the next layer of evidence. The darkness lasted 40 generations. And in that darkness, something was forged that would eventually become everything we now call civilization. But the cost of that forging was almost beyond comprehension. What they endured in those 1,200 years will challenge everything you believe about human resilience and about human fragility, because both were tested to their absolute limits, and only one of them survived. Chapter 8. The War for the Past. So now we stand at the crossroads. You have walked through the darkness. You have felt the cold. You have watched 35 genera vanish from a continent in what amounts to a geological heartbeat. You have seen the black mat, the nanodiamonds, the melt glass. But science does not work by accumulation of drama. Science works by competing explanations. And before we can reach the revelation waiting at the end of this story, intellectual honesty demands we confront the strongest arguments against the impact hypothesis. Because if the Younger Dryas impact theory is correct, it overturns decades of established understanding. And the guardians of that understanding have not been silent. The first competing theory is the oldest. It is the most entrenched. And for 30 years, it was considered essentially settled. It is called the overkill hypothesis. Proposed formally by Paul Martin in 1967, it argues that human hunters, not cosmic fire, drove the megafauna to extinction. The logic is straightforward. Humans arrived in the Americas. Large animals had never encountered bipedal predators with projectile weapons. They had no evolved fear response. Martin called it blitzkrieg. The evidence is not trivial. Kill sites exist. Clovis points have been found embedded in mammoth bone. The timing of human arrival roughly correlates with extinction waves on multiple continents. Australia lost its megafauna after human arrival. Madagascar lost its giant lemurs. New Zealand lost its moa. The pattern repeats. Humans arrive. Large animals disappear. For decades, this was enough. Textbooks printed it as fact. Museum exhibits were designed around it. The narrative was clean and compelling, and it placed human agency at the center of ecological destruction. But the overkill hypothesis has problems that its defenders have never adequately resolved. The Americas were not uninhabited before Clovis. Pre-Clovis sites now push human presence back to at least 16,000 years ago. Some evidence suggests 20,000 or more. If humans caused the extinctions, why did it take thousands of years of coexistence before the killing started? Horses survived in the Americas for millennia alongside human hunters. Mammoths persisted through multiple human cultural phases. Then suddenly, within a few centuries at most, everything vanished simultaneously. Overkill cannot explain simultaneity across an entire hemisphere. Furthermore, the extinctions were selective in ways that overkill cannot account for. Small mammals survived. Birds mostly survived. Marine mammals were largely unaffected. If humans were indiscriminate killers driven by population pressure, why did they target only large terrestrial species? And there's the African problem. Humans evolved alongside African megafauna for 200,000 years. Those animals developed fear responses and behavioral adaptations. Yet the overkill model cannot explain why African megafauna suffered significant losses during the same Younger Dryas window, despite having those evolved defenses. Something else was happening. Something overkill cannot contain. The second competing theory is more sophisticated. It argues that the Younger Dryas cooling was caused not by an impact, but by a massive freshwater pulse from glacial Lake Agassiz into the North Atlantic. This is the meltwater hypothesis. The mechanism is well understood. During warming, glacial ice dams weakened. When they broke, enormous volumes of fresh water flooded into the ocean. This fresh water, being less dense than salt water, formed a cap over the North Atlantic. It disrupted thermaline circulation. The Atlantic meridional overturning circulation slowed or shut down. Without that circulation bringing warm water northward, Europe and eastern North America plunged back into glacial conditions. The cooling was rapid. The mechanism is physically sound. Climate models support it. And this is important. The meltwater hypothesis is not wrong. Freshwater disruption almost certainly played a role in sustaining the Younger Dryas cold period. The question is, what triggered the initial catastrophic meltwater release? A gradual process does not produce the instantaneous onset recorded in Greenland ice cores. Temperature dropped several degrees within a single decade, perhaps within a single year. Meltwater rooting is a slow geological process. It cannot explain the violence of the transition. The meltwater hypothesis explains the persistence of the cold. It does not explain its beginning. The third competing theory is the most recent and perhaps the most subtle. It proposes that the Younger Dryas was triggered by a sudden shift in atmospheric circulation patterns driven by changes in solar output and volcanic activity. This volcanic solar forcing model points to evidence of increased volcanic aerosols in ice cores around the Younger Dryas boundary. Sulfate spikes suggest major eruptions. Reduced solar activity during this period could have amplified cooling feedback loops. The evidence is real. Volcanic forcing is a legitimate climate mechanism. The Little Ice Age of the 14th through 19th centuries was partly driven by similar dynamics. But like meltwater, volcanic solar forcing describes gradual processes. It cannot account for the instantaneous onset. It cannot explain the nanodiamonds. It cannot explain melt glass formed at temperatures exceeding 2,000 degrees. It cannot explain the platinum anomaly. It cannot explain the black mat. Here is what none of these competing theories can address. Each one explains part of the evidence. Overkill explains kill sites. Meltwater explains the sustained cooling. Volcanic forcing explains some ice core chemistry. But none of them explains all of the evidence simultaneously. None of them accounts for the layer of nanodiamonds found on 4 continents in the same stratigraphic horizon. None of them accounts for magnetic microspherules requiring temperatures far beyond any terrestrial fire. None of them accounts for the simultaneous burning of 10% of Earth's terrestrial biomass. The competing theories are not wrong. They are incomplete. They describe downstream effects while ignoring the upstream cause. And the upstream cause left its signature in a thin black line circling the planet. The debate continues. Careers have been built on opposing sides. Peer review has become a battlefield. Papers are published and challenged and retracted and republished in cycles that mirror the very catastrophic cycles we are discussing. But the evidence keeps accumulating, and the accumulation has a direction. It points upward, toward the sky. Chapter 9. When the evidence refuses to behave. Now we enter the territory where the story becomes strange, where the evidence stops fitting neatly into any single framework, where paradoxes emerge that challenge not just individual theories, but the very way we construct our understanding of the past. Because in the years since Firestone and West published their 2007 paper, the science has not stood still. New discoveries have emerged that make the picture both clearer and more troubling. Start with the platinum anomaly. In 2013, researchers analyzing Greenland ice cores found a massive spike in platinum concentration at exactly the Younger Dryas boundary. Platinum is rare on Earth's surface. It is common in certain types of extraterrestrial material. The spike is sharp. It is unmistakable. It appears in a single layer and then vanishes. This is not a signal produced by volcanic eruption. It is not produced by meltwater dynamics. It is not produced by human hunting. It is produced by something arriving from outside the Earth system. Then came the South American evidence. In 2019, researchers published findings from Piloco in Chile. At the Younger Dryas boundary, they found the same signatures: nanodiamonds, microspherules, platinum concentrations, charcoal layers indicating massive fires, and the simultaneous disappearance of megafauna from the South American record. The same boundary, the same chemistry. 12,000 kilometers from the proposed North American impact zone. A single bolide impact in one location does not scatter nanodiamonds across the southern hemisphere. This evidence demands a different mechanism, not a single impact. A swarm, multiple airbursts and fragments striking across a vast area simultaneously. This is where Victor Klube and Bill Napier's work becomes essential again. Their coherent catastrophism model proposed that Earth periodically encounters debris streams from the breakup of a giant comet. The Taurid meteor stream, which Earth crosses twice annually, contains fragments ranging from dust particles to objects potentially kilometers across. If a large fragment or cluster of fragments from this stream struck Earth 12,800 years ago, it would explain the geographic distribution of the evidence. Multiple impacts and airbursts across both hemispheres simultaneously. And here's the first paradox. We can see the Taurid stream. We pass through it every year. The annual Taurid meteor shower in late October and November is its visible manifestation. Astronomers have identified objects within the stream large enough to cause regional devastation. We know the threat exists. We watch it cross our orbit on schedule. And we have done almost nothing to catalog its most dangerous components. The second paradox concerns Göbekli Tepe itself. If Göbekli Tepe was built by scattered survivors at the end of the Younger Dryas, it represents a technological and organizational achievement that should have been impossible for small bands of traumatized hunter-gatherers. The site required coordinated labor, quarrying pillars weighing 20 tons. Transporting them without wheels or draft animals, carving them with precision that implies specialized knowledge of stone working, aligning them with astronomical references that imply sophisticated sky knowledge. This was not the work of people starting from nothing. This was the work of people remembering everything. The paradox deepens when you examine what was carved on those pillars. Pillar 43, the vulture stone, depicts specific animal symbols that University of Edinburgh researchers in 2017 correlated with stellar constellations. Using precession calculations, they dated the sky depicted on the pillar to approximately 10,950 BCE, the date of the proposed impact. The builders of Göbekli Tepe were not recording their own sky. They were recording a sky from 1,200 years before their time, a sky they had never seen. A sky that had been described to them across 40 generations of oral transmission. This means the information survived. Through the darkest period in human memory, through population collapse and cultural fragmentation and 12 centuries of cold, someone maintained the knowledge. Someone kept counting. Someone kept teaching. The third paradox is archaeological. Across the Younger Dryas boundary, we see not a gradual cultural transition, but an abrupt discontinuity. Clovis technology vanishes. The Magdalenian tradition fragments. The Natufian culture, which had been developing proto-agricultural practices, undergoes sudden disruption. And then, at the end of the Younger Dryas, complex behaviors appear with explosive speed. Agriculture, animal domestication, permanent settlement, monumental architecture, all within a few centuries of warming. The standard explanation is the Neolithic Revolution, a gradual accumulation of knowledge reaching critical mass around 10 to 12,000 years ago. But the timeline does not support gradual accumulation. The knowledge appears too quickly, too simultaneously, in too many disconnected regions. Agriculture emerged independently in at least 7 locations worldwide within roughly the same millennium. The Fertile Crescent, China, Mesoamerica, the Andes, New Guinea, West Africa, Eastern North America. 7 independent inventions of the same fundamental technology within the same narrow window after 200,000 years of anatomically modern humans not inventing it. This is not coincidence. This is not convergent evolution of ideas. This is the signature of preserved knowledge being redeployed when conditions finally allowed it. The fourth paradox is geological, and it remains unresolved. The Hiawatha crater beneath the Greenland ice sheet is real, 31 kilometers wide, consistent with an iron asteroid roughly 1.5 kilometers in diameter. The initial radar surveys suggested it could date to the Younger Dryas boundary, but subsequent analysis has pushed the dating back. Some researchers now argue the crater is millions of years old. Others maintain the dating remains uncertain because sampling through kilometers of ice introduces enormous error margins. If Hiawatha dates to 12,800 years ago, it is the smoking gun. If it does not, the impact hypothesis must rely on airburst events that leave no single dramatic crater. The absence of a confirmed crater has been the strongest argument against the impact hypothesis from the beginning. But the 1908 Tunguska event flattened 2,000 square kilometers of Siberian forest without producing a crater. The 2013 Chelyabinsk meteor injured 1,500 people and damaged 7,000 buildings without producing a crater. Airbursts are invisible to geology. They leave chemistry, not holes, and the chemistry is everywhere. The paradoxes converge on a single uncomfortable truth. Our methods for understanding the deep past are not designed to detect catastrophic discontinuities. They are designed to detect gradual change. When something sudden and violent occurs, our instruments interpret the aftermath as a mystery rather than a consequence. We see the effects. We resist the cause. And the cause keeps leaving its fingerprints in platinum and nanodiamonds and melt glass and a thin black line of death encircling the planet at a depth that corresponds to 12,800 years ago. The evidence is not ambiguous. Our willingness to accept it is. Chapter 10. What the darkness actually created. So here it is. The moment this entire journey has been building toward. Not the catastrophe itself. Not the evidence for or against a cosmic impact. Not even the 1,200 years of darkness and cold. The revelation is what happened inside the darkness. Because the true story of the Younger Dryas is not a story of destruction. It is a story of transformation so profound that everything you recognize as human civilization is its direct product. Listen carefully. For 200,000 years, anatomically modern humans lived on this planet without inventing agriculture, without building permanent settlements, without creating monumental architecture, without developing writing or metallurgy or mathematics as formal systems. This is not because they were stupid. Their brains were identical to yours. Their capacity for language, abstraction, tool use, and social organization was fully developed. They painted Lascaux. They navigated open oceans. They tracked stellar movements across decades. They were brilliant. And for 200 millennia, they lived in balance with their environment without transforming it. Then the sky fell. And within 1,200 years of unimaginable hardship, the survivors invented everything. Not because suffering made them smarter, but because catastrophe made certain knowledge existentially urgent. Before the impact, if your hunting ground shifted, you followed the herds. If a river changed course, you moved to another. If a plant became scarce, you found alternatives. Mobility was the universal solution. The planet was generous enough to absorb human flexibility. After the impact, mobility became death. The herds were gone. The forests were burned. The rivers were choked with debris or frozen solid. The plants you knew were buried under ash or eliminated by cold. Moving to another place meant moving to another version of the same devastation. For the first time in human history, there was nowhere else to go. And so the survivors did something unprecedented. They stopped moving, not by choice, but by necessity. They stayed in one place. They watched what grew in the ruined soil around them. They noticed which seeds survived the cold. They began to tend them deliberately. Agriculture was not an invention. It was a survival response to catastrophe. The earliest evidence of plant cultivation appears in the Younger Dryas itself. At Abu Huraira, before the site was flooded by the Tabqa Dam, archaeologists found evidence of rye cultivation during the cold period. Not after, during. People were farming in the darkness. Not because they had discovered a better way to live, because it was the only way not to die. And this changes everything we think we know about the birth of civilization. The standard narrative says civilization emerged from abundance. That warming climates and rich environments allowed humans to settle down and experiment with agriculture, which produced surplus, which enabled specialization, which created hierarchy, which built cities. The Younger Dryas evidence says the opposite. Civilization emerged from scarcity, from desperation, from 1,200 years of watching your children starve and resolving to ensure it never happened again. The granaries came first, before the temples, before the walls, before the kings. Someone decided to store food against future catastrophe. That decision required planning across seasons. It required defense of stored resources. It required social agreements about distribution and ownership. From granaries came settlements. From settlements came labor specialization. From specialization came hierarchy. From hierarchy came administration. From administration came record-keeping. From record-keeping came writing. The entire chain of civilization links back to a single traumatic necessity. Store food. Survive the cold. Do not let the darkness catch you unprepared again. But it was not only agriculture. The survivors also faced a problem no human generation had confronted before. The knowledge needed for survival was too complex and too urgent to trust to individual memory alone. Before the Younger Dryas, oral traditions were sufficient. Stories passed from parent to child could preserve cultural knowledge across centuries in stable environments. But the Younger Dryas destroyed stability. Communities fractured. Languages diverged. Populations dropped to levels where a single epidemic or failed hunt could erase an entire lineage of knowledge keepers. The survivors needed to encode critical information in forms that could survive the death of any individual, any family, any entire people. And so they carved it in stone. Göbekli Tepe is not the beginning of monumental architecture. It is the culmination of a 1,200-year project to make memory permanent. The astronomical alignments, the animal symbols representing constellations, the depiction of the impact event itself on Pillar 43. These are not decorations. They are data storage. The builders were creating a library that could not burn, could not flood, could not be forgotten, even if every living person who understood it perished. Because stone endures, and someone someday would find it and read it. They were writing a message to you. Across 1,200 years, across 40 generations, survivors on every continent faced the same impossible challenge and arrived at similar solutions. Store food, build permanent shelter, encode knowledge in durable form. Organize labor collectively. Watch the sky. The flood myths are not metaphor. They are curriculum. Every culture that preserved a story of world-destroying catastrophe followed by renewal was performing an act of survival education. They were teaching their descendants that the world can end, that it has ended before, that it will end again, and that preparation and knowledge and collective action are the only defenses. Noah was not a character. Noah was a lesson plan. The revelation is this. Civilization did not emerge because humans became smarter, or because the climate became friendlier, or because some culture stumbled onto agriculture by accident. Civilization emerged because a cosmic catastrophe 12,800 years ago destroyed the world that existed before, and the survivors spent 1,200 years building something that could withstand the next one. Every city you have ever lived in exists because someone 12,000 years ago decided to store grain against future disaster. Every library exists because someone carved astronomical data into a stone pillar so the knowledge could not die. Every government exists because survivors organized collective labor to build shelters and walls and monuments that no individual could build alone. You are the product of the Younger Dryas. Your language, your agriculture, your architecture, your religion, your science, your entire concept of civilization as something that can be built and maintained and defended against chaos. All of it was forged in 1,200 years of darkness by people who refused to let the species die. That is what was created in the cold. Not just survival, not just endurance, but the fundamental decision that humans would never again be helpless before a catastrophe. They looked at the sky that had tried to kill them, and they decided to understand it, to track it, to predict it, to build structures aligned with its movements so that future generations would know when the danger might return. Astronomy was not born from curiosity. It was born from terror. And the knowledge they encoded has survived, fragmented, mythologized, misunderstood, buried beneath layers of institutional resistance and academic orthodoxy. But it survived, because they built it to survive. The question was never whether a cosmic impact caused the Younger Dryas. The evidence will continue to accumulate until denial becomes impossible. The real question, the one that changes how you understand yourself and your species and every structure you have ever taken for granted, is this. What are you building that will survive the next one? 12,800 years ago, the sky burned, the world froze. And in the space between extinction and survival, human beings made a choice that echoes in every stone foundation and every planted seed and every story told to a child at night. They chose to remember, not just what happened, but why it mattered, and what to do when the sky falls again. The torrid stream still crosses Earth's orbit every year. The debris field contains objects we have not yet catalogued. The cycle that Klube and Napier described has not ended. It has only paused. We are not observers of this story. We are participants in it. The same sky watches us. The same debris field circles the sun. The same question that faced the survivors of the Younger Dryas faces us now. Will we remember what they tried to tell us? Göbekli Tepe still stands. The black mat still marks the boundary. The platinum spike still gleams in Greenland ice. The myths still carry their warnings in languages we have only begun to decode. The thread stretches from their hands to ours. 40 generations of darkness could not break it. 12,000 years of forgetting could not erase it. Do not let it break now. The story of the Younger Dryas is not finished. It is not ancient history locked safely in the past. It is a continuing process, a cycle measured in millennia. And we are somewhere inside that cycle right now, looking up at the same sky, asking the same question they asked. What comes next? If this journey changed how you see the past and the sky above you, subscribe to this channel. Share this with someone who needs to hear it. Because the next chapter of this story is not behind us. It is ahead. And it belongs to whoever is paying attention.